So welcome to day 3 of revision series. As usual, before starting the session, let's start with a silent prayer. Can we? So in the last class, we completed measure of the last day session. We completed measure of central tendency, measure of dispersion, measure of correlation, and we were yet to proceed with sums in correlation and the conceptual clarity of regression. Let's have a quick look on what is meant by correlation. Correlation is nothing but it measures the interdependency between two variables. If you want more explanation on how this interdependency works, you can convert this correlation value into percentage just by multiplying 100, which means to what extent, what is the percentage of control or what is the percentage of effect there will be in another variable when there is a change which is increase or decrease in one variable. This is what we call it as correlation. And we had the example of demand and supply to understand correlation. Now we will be using two formulas to understand correlation. The two formulas were, very first one is Karl-Pearson's correlation, which is nothing but covariance between two variables x and y divided by standard deviation of, like, product of standard deviations of both the variables. Now what is meant by this covariance? Covariance we also call it as combined variance. While finding variance, we will do the square for deviations from arithmetic mean. Instead of making the square from square of deviations, if I make it as product of deviations of two variables, it is called as combined variance. Instead of using the combined variance by product of standard deviation, we also have a much simpler formula, which is n sigma xy minus sigma the n times summation xy minus summation x summation y divided by root of n times summation x square minus summation x the whole square into root of n times summation y square summation y the whole square. So this is the formula we will be using. As discussed in central tendency and dispersion, there is also one effect of change in origin and change in scale. In case of change in origin, there is no effect of correlation coefficient, it remains as it is. Whether it is translated or not, the correlation coefficient remains the same. Similarly for magnification, that is change in scale also, it remains the same, but the direction of change in scale will affect the correlation coefficient. That is what we have discussed earlier. Correlation coefficient is affected by direction of change in scale. Direction of change in scale. And we also discussed another type of correlation, which is if the value of R is equal to plus or minus 1, we call it as perfect positive correlation or perfect negative correlation, which means whatever the change in one variable, the exact change or to the same extent of change will be there in another variable also. Next one is Spearman's rank correlation. This rank correlation is not studied to have the relationship between two variables. Instead, it is studied to have the relationship between or interdependency between two observers. Two observers observing a same variable will give two different judgments. Is there any interdependency between those two judgments? That is what we will discuss in Spearman's rank correlation, and the formula for Spearman's rank correlation is 1 minus 6 times summation d square, where this d is nothing but the difference between rank of both the judges. We will make the square for the difference. 6 times d square divided by n into n square minus 1 will give you the answer for rank correlation. And if there is any repetition in rank among one judge, the number of repetitions of one rank will be taken as m. If one rank got repeated 3 times, we will take the m as 3. So we have to adjust this factor in order to avoid the error because of that repetition of rank. This is what we have discussed in the earlier class, and we have also discussed what is the formula. It's just a formula thing, probable error and concurrent deviation. Now, we have to proceed with the sums on correlation. Can we? Now, can we? Yeah. Can we have the discussion on the questions? Correlation measures the relationship between two variables. Scatter diagram with points close to a straight line indicates. Okay, what is meant by scattered diagram? Let's discuss what is meant by scattered diagram. See, scattered diagram is nothing but plotting the change or increase or decrease in one variable and the same effect of another variable in a graph. This is what we call it as scattered diagram. For example, if we are considering two variables and I am observing a change in one variable, if there is an increase in change, if there is an increased change, I am plotting it as increased change, and in a corresponding manner, if there is an increase or decrease, I am observing. If there is an increase, I am just observing like this. So this point represents how one unit of my reference data got changed just because of change in another variable. Now, by plotting this, and if I try to trace how this plotting works, this is what we call it as scatter diagram. Just by analyzing the scatter diagram, we can conclude what correlation exists in between those two variables. Here, what is the question? Scatter diagram with points close to a straight line indicates. Points close to a straight line. So, it can be either like this or like this. Indicates high correlation. So, it can be positive correlation or it can be negative correlation. So, we call it as strong correlation. Then, if R equal to 1, correlation is perfect positive. Then, if R equal to 0, the variables are unrelated. The variables are unrelated. Now, Calpearsons R lies in between. Just now I mentioned this correlation coefficient lies in between plus or minus, plus and minus 1. Technically we have to use the symbol rho, but if the data set itself is a sample from population, we will be using R instead of rho. So the answer is -1 to +1. Rank correlation is used for rank data, quantitative or rank data, not just quantitative data, because whatever the data we are using in normal correlation, Calpearson correlation is also a quantitative data, but if it is a ranked one, Calpearson's, that is Spearman's rank correlation will be used. Perfect negative correlation will be indicated by -1 if points lie exactly on upward line. If points lie exactly on upward line, upward line is nothing but this line. We call it as R is equal to +1. Now, correlation does not imply. What does correlation does not imply? We can't see what is the data hidden, what type of data we took, whether the data contains 1 unit, 2 unit, we don't know about that. We just know relationship, variation measure, that is constant of variation, like what is the proportionality constant, causation, what that is effect, causation is nothing but effect. These and all we will be able to measure in correlation, but we won't be able to see how the data is placed. Covariance is positive when the variables move in tell me, you mentioned if it moves in upward direction, right? Let me take an example. Let me take x, two variables x and y, 10, 20, 30, here 1, 2, 3. It's increasing and you are mentioning it to be upward curve, positive correlation. Now 30, 20, 10, 3, 2, 1. Now tell me, it is in downward direction. Is it in downward direction? Will the curve be in downward direction? No. The same curve will be in positive direction, whereas the order of data you are considering is not in increasing one, it's a decreasing one. Even if it is a decreasing one, the other variable is also decreasing. So positive correlation represents increase and increase in both the variables, decrease and decrease in both the variables. Then what is negative correlation? One variable will get increase and another variable will get decrease and vice versa. Clear? Not exactly decrease represents negative correlation, increase represents positive correlation. Increase in one variable or decrease in one variable will also represent positive correlation. So covariance will be positive, which means correlation is positive. Same direction. It's not in upward direction, it's not in downward direction. Both of them are same only. Both of them will give you a positive result only. So it is same direction. Purida? Clear? Now, if covariance is 0, then the correlation will also be 0. Correlation is independent of change in scale only. Direction of change in scale should be measured. A scattered cloud with no pattern indicates pattern என்னங்கிறத சொல்ல முடியல. Zero correlation. Line of best fit is called as regression line. If x and y are in correlation, No, it's something question is wrong. Okay, x and y in correlation are called as variables. Deviations means measures. Variables. X minus x bar the deviation. X minus x bar will be deviation. Whereas the variable value, that is x and y, we call it as variables only. I just took few examples from correlation, few example problems from correlation. Anyway, I will share you the problem set, my own problem set for correlation. It contains around 100 questions. Just a minute, let me share it. So till now we have discussed the problems in correlation. We are yet to proceed with regression. This regression is nothing but in earlier class we discussed correlation, which measures the interdependency between two variables. How one variable, the change in one variable affect another variable, that is what we have discussed in correlation. But when it comes to regression, instead of discussing just an impact on another variable, instead of discussing just the impact of change of one variable on another variable, this regression will give a linear relationship between two variables. What's meant by that linear relationship between two variables? That is, it will give you a line, y equal to a plus bx, which gives you the value of y for every change in x, For example, if y is supply, if I take this y is supply, then x can be demand. So I have written the equation for demand and supply, where demand is the independent variable and supply is the dependent variable. If there is an increase or decrease in demand, how supply will get affected, that is what I have written. So here y will be the dependent variable and x will be the independent variable. But when it comes to correlation, we will be discussing two variables, right? Correlation is nothing but interdependence. How two variables are interdependent, not just dependent, interdependent, which means that interdependency will act on both the ways. Now we will be discussing two regression lines. What's this y equal to a plus bx and x equal to c plus dy? In this case, y will be the dependent variable, x will be the independent variable, and y will be the dependent variable. Y will be the dependent variable depending on x, right? So I call it as, just because it is dependent on x, I call it as y on x. Similarly, in this scenario, y will be the independent variable and x will be the dependent variable. X will be the dependent variable. So we will be calling it as x on y. Dependent variable on x, dependent variable on y. So we will be calling it as x on y. X dependent on y. We will be calling this thing as y dependent on x, so y on x. Mathematicians never play with just numbers, they also play with some English words. Can we? So, how to compute this? How to compute this? That is what we are going to see now. Y on x. The basic formula for finding y on x equal to a plus bx. Here x equal to c plus dy. These are nothing but just constants. These are nothing but constants, and we will be naming this constant in a different way. I am just going to have few basic mathematics here, which is you have y1, y2, y3. You will be having a series of values for y. Similarly, you will be having a series of value for x. What will happen when you add all the value of y? That is, you can write y1 is equal to a plus bx1. The relationship between first y. You don't know what is a and b. Similarly, y2 is equal to a plus b x2, and goes on. Yn is equal to a plus b xn. The sum of this will give you summation y is equal to what will happen when you add one constant number n times na plus b times summation x. Clear? Similarly, instead of taking it as just y, multiply it with x. Multiply it with corresponding x value. What will happen? X times y, what x1 times y1 equal to ax times b x1 square. x2 times y2 equal to ax2 times b x2 square. x3 times y3 is equal to ax3 plus bx3 square, and goes on. And if I try to add all of those, I will be getting summation xy is equal to a times summation x plus b times summation x square. See, from the data available with you, you will be able to get summation y, summation xy, summation x, summation x square, all these things, right? Try to equate it in this equation and solve by elimination method. Solve the above by elimination. You will be getting a and b. And when you try to get that value, when you try to get that line, you will be getting y equal to a plus bx. It will give you a straight line, and I am placing that straight line in the scale something like this, in the graph something like this. Similarly, in a similar manner, I will be doing the same for x on y. So what will happen? Summation x is equal to nc plus d times summation y. Summation xy is equal to c times summation y plus d times summation y square. Solving these two will give you, solving these two by elimination, basic elimination will give you c and d. And when you try to plot it in the same graph, you will get one another line something like this. Now these two were lines, right? Obviously these two lines will intersect at a point. Obviously these two lines will intersect at a x and y. That x and y is nothing but the common point for both the lines, which is x bar comma y bar. So what does it mean? Two regression lines intersect at arithmetic mean. To be more specific, two regression lines intersect at central tendency or the expected values. Two regression lines intersect at expected value of each variables. Expected value is nothing but mean. Expectation is such a good concept, but unluckily you are not having it in your foundation. Can we? Sir, is there any other formula? Yes. Y equal to a plus bx is one formula. We can also try to find the same with the help of deviations, similar to one which we discussed earlier, which is y minus y bar is equal to b. Here the regression is y dependent on x, right? The regression line is y dependent on x, so it will be byx times x minus x bar, and here it will be the same will be x minus x bar is equal to bxy times y minus y bar. Clear? Sir, what is this bxy and byx? These two were called as regression coefficients. These two were called as regression coefficients. Either both will be negative or both will be positive. One negative, one positive, not possible. Now how to compute this byx and how to compute this bxy matters. Take the correlation coefficient. It's byx. What is the independent variable? X. Y on x, so it will be x. The independent variable will be x. Divide it with the standard deviation of dependent variable. Multiply it with the standard deviation of dependent variable. So divide it with the standard deviation of independent variable and multiply it with the standard deviation of. The same rule is applicable here also. Now, wait. Is it possible to rearrange this? Yes. Yes, it is possible to rearrange this in a similar manner which we did for correlation, which is n times summation xy minus summation x summation y divided by n times summation x square minus summation x, no root. You don't need to put root here. Similarly here, n times summation xy minus summation x summation y divided by n times summation y square minus summation y the whole square. The same formula, same type of formula. Instead of like you don't need to put a root here. You can also use covariance to do it. Covariance between x comma y. Here it is covariance between x comma y. Instead of the exact value summation xy, summation x, summation and y, if you are given with mean of each variables and mean of the product, mean of each variables and mean of the product and mean of the squares, if you are given something like that, in such situation xy by n minus x bar y bar divided by x square, summation x square by n minus x bar the whole square. Here it will be summation xy by n minus x bar y bar divided by summation y square by n minus y bar the whole square. Can we? Now we have discussed the regression coefficients bxy and byx. What will happen when we multiply these two things? Multiply. Both the numerators are same. Denominators, this denominator is nothing but kind of it gives you the variance of x, kind of it gives you the variance of y. So the product of bxy and byx will give you r square. So in order to find r, you can just take the square root of the regression coefficients. But what can be the sign of such correlation coefficient? When you try to take the square root, the answer can be positive or the answer can be negative. What can you say about the sign now? Plus or minus, it's not possible. When it comes to this sign, depends on the sign of bxy and byx. It depends on the sign of bxy and byx. As I mentioned earlier, both of the regression coefficients will be having same sign. Both of the regression coefficients will be having same sign. In such case, such sign can be adopted to tell what can be the correlation. Entire regression in one page. Enough. In regression, the concepts are over. So, correlation coefficient is nothing but the geometric mean of two regression coefficients. Correlation coefficient is nothing but the geometric mean of two regression coefficients. Can we? Can we? Let me take a sum. I have two regression equations. 3x plus y is equal to 13 and 2x plus 5y is equal to 20. Which one is regression coefficient of y on x and which one is regression coefficient of x on y? Which is x on y and which is y on x? I will tell how to find it and I will also give you a trick to find it. Let me assume this one as y on x. So it should be written in the format of y equal to a plus bx. So y equal to 13 minus 3x. So what is b here? Minus 3. If this is y on x, this should be x on y. This should be x on y, so it should be written in the format of x equal to c plus dy, which is 2x equal to 20 minus 5y, x equal to 20 minus 5y divided by 2, just 20 by 2 minus 5 by 2y, 10 minus, so what is b here? This is b yx and this is b xy minus 5 by 2. bxy into byx equal to minus 3 into minus 5 by 2. What's minus 3 into minus 5 by 2? R square, right? What can be R? See, both the regression coefficients have negative symbol. Both the regression coefficients have negative symbol. What is 7.5 square root? Square root of 7.5? 2.73 minus 2.73. So your correlation coefficient is minus 2.73. Sir, wait. You have asked us to find which one is a regression coefficient, regression line on y on x. But you have found correlation coefficient. நீங்க என்ன லூசா சார்? ஏன் சார் இப்படி வரீங்க? Is my correlation coefficient correct? Correlation coefficient should always lie in between plus or minus 1. So my initial assumption itself is wrong. We have to change the assumption. So this is x on y, this is y on x. So the answer is 2x plus 5y equal to 20 is the regression equation of y on x. Clear? Sir, is there any shortcut? Yes. I am taking the very first equation as 3x plus y minus 13 is equal to 0. And the next one as 2x plus 5y minus 20 equal to 0. Can I try to do a cross multiplication? Try to do a cross multiplication. Sir, how to do it? How to do a cross multiplication between two equations? Now you have to tell which is A, which is B, which is C. Which is A, B, C, A1, B1, C1, A2, B2, C2. We have to identify and we have to substitute here. அப்படியெல்லாம் போகிறதுக்கு பதிலா let's do a simple thing here. Let's do a simple calculation. It's so simple to calculate. This is my first equation, right? This is my first equation, right? Take the middle coefficient 1. Come towards the right. Then the same one. Similarly, 5 minus 20, 2 and 5. Multiply minus this, which will give you the answer of B1 C2 minus B2 C1. Obviously, this is B1, this is C1, this is A1, again this is B1, this is B2, this is C2, this is A2, this is B2. Now, B1 times C2, B1 times C2 minus B2 times C1. Minus 20 plus 65. Minus 20 plus 65. Minus 20 plus 65. What's the answer? $45. Here minus 26 plus 60. It's 34. And here 15 minus 2. And both of these will be equal. This will be 1, and let me take it as here my unknowns are, here I am having different unknowns, x and y as different unknowns, right? So let me take it as x and let me take it as y. So you will be able to solve till this, right? You will be able to solve till this. Here, wait. Take which one is the smaller number. Try to find which one is the smaller number. 34, right? Which is second one. So in such scenario, after doing the cross multiplication, the smaller one is y on x. Greater one is x on y. Which is the second equation is y on x. That's what we have discussed. And the greater one is x on y. Clear? Can I proceed? Similarly, how to find R? How to find R? Similarly, how to find R? The same thing. These two were some short tricks when it comes to regression questions. Obviously, couple of questions will come from this area. Find the regression. Which one is which regression line? And from the two given regression line, try to find the correlation coefficient. The main thing is you have to assume one regression line. You have to assume one regression line as y on x or x on y. Then only you will be able to proceed with that. Similarly, to find R can be written as R is nothing but in both the situations, y is having the same sign, yes or no? Y is having the same sign. Take the opposite sign. So I am taking it as negative. So it will be something like not plus or minus, it will be minus or plus. If both the y coefficients have a positive sign, take it as a negative one. If both the y coefficients have a negative sign, take it as a positive one, times root of smaller divided by larger. Was expecting you. Thank you. Shirt nalla irukna. Now try to find what can be the regression, what can be the correlation coefficient, which is smaller one, 1 or 3, sorry 1 or 5, 1. So it's nothing but minus root of 1 by 5, minus root of 1 by 5. If you want, you can also cross verify that. So this is our y on x, this is our x on y, yes or no? This is our y on x, this is our x on y. So if this is y on x, how can I write this? How can I write this? 5y equal to 20 minus 2x. So y equal to 20 minus 2x by 5. What is the regression coefficient? Y on x. Okay, this is y on x. What is byx? Minus 2 by 5. Similarly, here, how can I write it? X on y. So 3x equal to 13 minus y. X equal to 13 minus y by 3. What is bxy? Minus 1 by 3. Byx is minus 2 by 5. Bxy is minus 1 by 3. Now, just cross multiply both of this. It should be 3x. It should be 3x. Technically, it should be 3x. It's not 2x, it should be 3x. So it will be minus 3 by 5. 3 will get cancelled. Root to minus 1 by 5. Yeah. Minus into minus plus. So root of 1 by 5. Both of them are having, here in equation, both of the y coefficients are having positive sign. So you have to include a negative sign. If in the equation itself both of them are having, both of the y coefficients are having negative sign, what you have to do? You have to include a positive sign. That's why I have included it as minus or plus, not as plus or minus. Purila. What's the coefficient of y? What's the sign of y here? Plus. Here? Here also plus. So in both the scenario, y is having the same sign. Then, if it is positive, the correlation coefficient will be negative. So that's why I have initiated it as minus. If you are having plus inside, it should be minus. The correlation coefficient should be minus. If the coefficient of y is negative in both the scenarios, then the correlation coefficient will be positive. So that's why plus. It's minus or plus root of smaller number, smaller coefficient divided by larger coefficient. Clear? Now, let me tell you one more trick to find which one is which regression coefficient. Like we discussed the trick to find which one is which regression coefficient, how to find the correlation coefficient, how to find the regression coefficient we can discuss. In the earlier case we discussed how to find a regression line only we have discussed. Now we are going to discuss how to find such regression coefficient, how to identify such regression coefficient. Let's discuss. I am having ax plus by plus c equal to 0. If this is regression equation of y on x, then byx is equal to, then byx is equal to minus coefficient of x divided by coefficient of. Similarly, if the same, this is regression equation of x on y, if this is regression equation of x on y, then bxy is equal to minus coefficient of y divided by coefficient of, that's it. That's it. What is the regression coefficients? We found this is regression coefficient of y on x minus coefficient of x divided by coefficient of y. 3 by 5. I mentioned no, this is 3. Clear? Similar to correlation coefficient. Similar to correlation coefficient, regression coefficient also remains unchanged by change in origin. Change in scale matters. Change in scale matters. If you can write u equal to x minus a by p and v equal to y minus c by q. What's this? Change in origin. What's this? Change in scale. Similarly, this change in origin, and this is change in scale. Yes or no? And you found bxy, like you have to find bxy and you have to find byx. You found buv and you have found bvu. How can I relate these two? How can I relate these two? That's the question here. What's the independent one? Y, right? Take the change of scale in y. Change in scale of x. Similarly, take the change of scale in x divided by take the change of scale in y. That's it with the linear relationship between change of scale. That's it. Not only sign, also the value differs. It depends upon the change in scale on both the regression coefficients. That's why instead of telling it through Excel, through a practical problem, I took this as a linear relationship itself. With this, the conceptual things of regression is over. I will give you a 10 minutes break. Let's start with problems on regression and proceed with other things. Okay, Gavaniyala. So continuing further, upon your request, let me have one problem discussion on this topic, change in scale and change in origin. For that purpose, let me take Excel. I am having x. Let me take one book sum x and y, something like this. 20 11, 15, 10, 19, 21. What is the value of y? 5, 15, 14, 17, 10, 11. That's it. So I have to find total. I have to find the total. Now what's the next step I have to do? X square, y square, xy. X square, y square, then xy. What is x square? 400. And here what is y square? What is xy? 20 star 5. I am doing the same for all the remaining. Now what's your bxy? What's the formula for bxy? What's the formula for bxy? For bxy alone I am doing. Byx you please try. What is bxy? What's the formula for bxy? இந்த பக்கம் வந்து உட்காந்துக்கோ, பின்னாடி இருக்கிறவங்க மூஞ்சி எனக்கு தெரியல. What is the formula for bxy? It's nothing but with the given information n times summation xy. Summation நான் எங்க போறது? Let me have it as sum xy minus sum x, sum y, divided by n times sum y square minus sum y the whole square. This is the thing, right? I'm just writing it as a linear one. Formula, you know the formula, n times summation xy minus summation x summation y divided by n times summation x square minus summation x the whole square, which is, what is n here? 6 star. What is summation xy? 1066 minus, what is summation x? 96, summation y 72. So have it as a practice while executing Excel or any mathematical operation. Try to include or try to use as much as brackets possible, just to avoid any confusions. Divided by 6 times summation x square, summation y square minus summation y clear. This is the regression coefficient. Minus 0.93478. Okay, let it be. Now I am just going to convert this x into some u equal to, I can take 10 as a common one, or 10 எடுத்துக்கலாமா 11 எடுத்துக்கலாமா, anything. I am just taking x minus 10. Let me see what happens. Equal to minus 10. So 10 is not a good one. 18. So if possible, try to take a number so that the total becomes 0. நானா போடுறது தான்ப்பா, சும்மா நானா போட்டுட்டு இருக்கேன். It's on my own choice. Okay, I'm just getting a number like this அப்படின்னு வச்சுக்கோ. Now I'm just multiplying or I'm just dividing the number by 2 in order to let you know the effect of change in scale. In order to let you know the effect of change in scale. So wherever you okay, let it be something like this. Let it be something like this. Now I'm taking V as, it seems V is எப்படி இருக்கு, here. Just checking if possible we can be written something like here. My answer only matters, right? So I have converted my sum itself into a different one. So V is nothing but y divided by 5. Y divided by 5. Okay. Now what's the sum here? பரவாயில்லையே, நான் எடுத்த 16 is the actual mean of this entire x, entire variable value x. Yeah, sum of deviations is 0. So 16 itself is mean. Now what can we, how can we compute the answer for BUV? BUV we have to find equal to the same formula only. Wherever you get xy, you have to replace it with uv. Wherever you get x, you have to replace it with u. Wherever you get y, you have to replace it with v. Clear? Which is for that I have to find u square. I forgot to find u square. I have forgot to find v square. Then it will be uv. U star v. Wait. Instead of taking this y divided by 5, let me take it as y divided by minus 5, just to let you know change in direction, just to have the impact of change in direction. Here we have only change in scale. Here we have the magnification in the opposite direction. Clear? Minus 5. Clear? Now n times summation uv equal to 6 times, what is summation uv? Minus summation u, summation v. What is summation u? 0. What is summation v? Minus 15 divided by 6 times summation v square. Summation v square is 43. Summation V, the whole square, minus 15 times minus 15, right? Clear? Now, what can I say about, or how can I relate this minus 0.8 with 4? I have to relate this minus 0.8 with 4. I have to relate, wait. We had the discussion on one problem to understand the change in scale and change in origin. Let me take that problem into my sheet itself. Okay. Here, I took the value of x, I took the value of a random value of x, a random value of y, x square, xy. So I found the value of bxy. Similarly, I have converted u into, like I have converted x into u in terms of change in origin, and I have converted y into v in terms of change in scale, that to negative magnification, here what is your x, how, like x is written in the format of x minus a by p. X should be written as, like u should be written as a by p, u should be written as x minus a by p. What is that a? 16 divided by p is 1, and v should be written as y minus c divided by q. So that q is minus 5, that is minus 1 by 5. Wait. Yeah, q is minus 5. So this is your q and this is your a. Is there an impact of change in origin in BUV and BUV and BVU? No. There is no impact of change in origin. There is only an impact of change in scale. Now we have found what is BXY. What is the formula for BXY? N times summation XY, which is 6 times 1090 minus summation X summation Y, which is 96 into 75. 6 times 1090 minus 96 into 75 divided by 6 times summation y square, which is 1075 minus 75 the whole square. Try to execute. What's the answer? Numerator, what's numerator?
Minus 660.
Minus
660.
Minus 660 divided by
Minus 75 square.
75 into 75.
10 equal.
What is 6 times 1075?
6450.
6450 minus, what is 75 times 75?
5625.
5625.
825.
Denominator it is 825, right? So minus 660 divided by 825. Minus 0.8. It's minus 0.8. It's not minus 1. It's minus 0.8. Now we have to find how can we equate this minus 0.8 towards 4? What is BUV? Similarly, BUV is equal to 6 times summation uv, which is 22, minus summation u into summation v, 0 times it will be minus 15. So anyway it will be 0 divided by 6 times summation v square, which is 43. 6 times 43 minus summation v minus 15 the whole square. 6 times 22. What is the answer?
132.
என்னப்பா? 132. அப்படியா? Okay. Divided by 6 times 43? 258 minus 225. The answer is 132 divided by 256 minus 225, 21. 31. 31. Okay. 132 divided by 31. 6 times 43. It should be 258. 258 minus 225. The answer is 4. Now, how we are going to relate this minus 0.8 and 4? That is the question here. Change of scale and change of origin. I repeat. 2 questions, 2 to 3 questions will come from, or at least 2 questions will come from this area. Change in scale and change in origin. From correlation, from regression, from central tendency, dispersion, for sure change in scale and change in origin will come. Now, we found that bxy is equal to what is the change in scale in another variable? What is the change in scale in the, see here xy, y is the independent variable, x is the dependent variable. What is the change in scale in the independent variable? What is the change in scale in the independent variable?
1 by q.
It's q. Q should be minus 5. Okay, 1 by q. As mentioned, 1 by q is the change in scale. It's minus 5 divided by what is the change in scale in the dependent variable? 1 times buv. What is buv? Mari varudhu. Wait. Just wait a second, I just made a small error here. Always dependent variable should be in the denominator, right? Always dependent variable should be in the denominator. So it should be q and p here. So the answer should be minus 5 should come in the denominator. 1 divided by minus 5. Now put the answer. Minus 1 into 4 divided by 5. So the answer is minus 4 by 5, which is minus 0.8. That's the value of bxy. Always you should have the any related term towards the independent variable should be placed in the denominator. Any related terms of, let it be change in scale, let it be standard deviation, whatever it may be, it should be placed in the denominator. Clear? The regression original class on the that's why I asked. Clear? Can we discuss few problems? regression predicts the value of regression lie of y on x predicts y from x. Slope of regression line is called regression coefficients. Slope of y equal to a plus bx, that is what we have found, right? That is the regression coefficient of y on x, right? In your lower standard you might have heard about the term y equal to mx plus c. Y equal to mx plus c, that m is the slope of that line, that m is nothing but b. If you want, you can also, if you are that much interested, this regression coefficient is nothing but the first derivative of the entire line. First derivative of the entire line with respect to x or with respect to y. If you try to differentiate with respect to x, that is the first derivative of b on x, b yx. If you try to differentiate with respect to y, that's b x on y. Now, two regression lines intersect at mean of x and y. Byx into bxy r square gives r square. See, I took this questions on out of hurry, so you won't be getting that xy in suffix etc. things. Try to understand, if read it as bxy, which is regression coefficient of x on y multiplied with regression coefficient of y on x. It's not the product of b, that is product of b with x with y. It's not the product. Regression line always pass through mean of x and mean of y. If r equal to 0, if there is no correlation, if r equal to 0, what can you conclude about regression coefficients? Parallel, perpendicular, coincident, identical. Why? Just now, few minutes back, I gave you a hint for that. Can we try to interrupt mathematically? They have mentioned regression lines, that is r equal to 0. R equal to 0 represents covariance between x comma y is equal to 0. Right? Covariance between x comma y is 0. So obviously bxy, which is equal to covariance of x comma y divided by what is bxy? What should be in the denominator? Independent variable, that is the variance of independent variable, which is y square, right? That is also 0. That is also 0. I have to find bxy, means what is the line, how the line can be? X equal to c plus dy, right? Some c plus dy, that d is nothing but bxy times y. This is 0, which means c plus 0, x is equal to c, which means on a graph you will be getting, what is this line? This is y equal to 0, this is x equal to 0. Any line which is parallel to x axis, at a distance of a, we call it as y equal to a. Similarly, any line parallel to y axis at a distance of b, we call it as x equal to b. Here x equal to 0, this is x equal to b. All the points in that line will have y coordinate as b. Sorry, x coordinate as b. Similarly, all the points in this line will have y coordinate as a. That's how you can name a line. That's how you can give a name towards a line. Now we found what? X equal to some C. We have found x equal to C. What is that x equal to C? Let me take this line itself as x equal to C. I don't know how to erase this. No, it won't be good. Just a minute. Okay, let me name it as x is equal to C. X equal to C. Now this is my entire line. This will be my entire line. Similarly, if I try to find b of, like I found b y x y. Similarly, if I try to find b y x also, it will be 0. B y x will also be 0. Similarly, I will be getting y equal to some a. Some y equal to a. So this equation is, this line is y equal to a and this line is x equal to c. How these two lines are? How these two lines are? Perpendicular. These two lines are perpendicular. So the answer is perpendicular. Answer is perpendicular. Two lines, regression lines are perpendicular to each other. And both the lines, this is nothing but the arithmetic mean of the line x, and this is nothing but the arithmetic mean of the line y. Sorry, this is the arithmetic mean of x and this is the arithmetic mean of y. Can I proceed? Purila. Purida Purila. Where you are not getting, it seems you are not getting a point. Where?
Like question full
If r equal to 0, the regression lines are whether it will be parallel, perpendicular, coincident or
to each other. On the line
yeah, to each other, exactly. You are Purila. But you thought the answer should be parallel. Okay.
Parallel same direction, so r is 0.
If r is exactly plus 1, it can be coincident or it can be parallel also. It can be coincident or it can be parallel also. It can be like this or it can be like this. Then for you, can I proceed? Regression coefficients are affected by not change in origin, change in scale. Yes, obviously it is affected by change in scale. The magnitude of change in scale itself affects regression coefficients. Predicted value of y is written as, it's y cap. Regression coefficient y on x, it always depends. We can't conclude then and then. It always depends. Can be anything. But if one regression coefficient is greater than 1, other should always be lesser than 1. The converse is not true. The converse is not true. Both the regression coefficients can be lesser than 1. But if one regression coefficient is greater than 1, the other should always be lesser than 1. Models. I am speaking about models.
Both A and B கொடுத்தா
என்னப்பா?
Suppose both A and B கொடுத்தா like maybe
that's what depends. It depends upon the scenario. Regression is used when the variables show functional relationship. Yesterday you asked this question, right? Function. It's a functional relationship. A functional relationship is nothing but function of function. Functional, the meaning of functional is that is input of a function itself is another function. What is the input of the function here?
Like FOG.
Yeah, kind of. What is the input of the function here? Bxy or Byx?
B.
What's the another output function here?
X.
Regression line itself is a function here.
Okay.
Y of something. Y of something that depends on Byx. So Byx itself is a function. We will be writing it with the help of R. So that's why it's a function of function, functional relationship. I am not giving you the exact term of functional, but for understanding I am telling it. It's a higher mathematics concept. Functional, the term functional itself is a higher mathematics concept. How like for commerce students or for CA or CMA students in foundation level, mathematics may seems to be a nightmare paper. May I'm not telling always, may seems to be a nightmare paper, but for me, in spite of this subject being, this functional subject being one of the most subject, my favorite subject, in spite of that subject being most favorite one, it's a nightmare subject for me during my higher studies. Functional. Can we? If Bxy is positive, the relationship is okay. We don't know what is Byx. Bxy is positive. We don't know what is B. What can we say about R? The sign of R depends on both the sign of Bxy and Yx. Both Bxy and Yx will have the same sign. I mentioned it, right? Both Bxy and Yx have same sign. If Byx is positive, then Bxy will also be positive. Correlation coefficient will also be positive. Then the relationship is a positive relation. When it will be a negative relation? When one is negative, that is the correlation coefficient is negative, which means increase in one variable result in decrease in another variable, and vice versa. When it will be inverse? Okay, when it will be 0, R is equal to 0, it will be 0. When it will be inverse? Perfect negative. When it will be symmetric? When it will be symmetric? Perfect positive. Perfect positive. Can we? Angle between regression lines decreases. What can we say here? Angle between regression lines. It's a nice question. It's a nice question. You need to understand how to interpret this question. Say, let me take the first angle. Let me take the first angle as theta 1 and the second angle as theta 2. Obviously, theta 2 is bigger one. I have to find theta 2 minus theta 1. That's the angle between two regression lines, right? That's the angle between two regression lines, theta 2 minus theta 1 or theta 1 minus theta 2, whatever it may be. I am taking it in the positive sense, so it will be theta 2 minus theta 1. I am taking it in anti-clockwise, so I am considering it as theta 2 minus theta 1. Regression coefficient is nothing but slope, right? You have another name for slope, which is tangent. Right? Tan A minus B formula. Tan A minus B formula.
Tan A minus tan B by 1.
Those people who don't know mathematics, those people who haven't studied mathematics in 11th and 12th, leave it. Leave it. Let me give the formula. Tan of A minus B is equal to tan A minus tan B 1 plus tan A tan B. You know what is tangent, right? How to take tangent for an angle? Tangent for an angle. Build a triangle. Wait. Build a triangle. Place one angle as theta, opposite, adjacent, hypotenuse. The ratio of opposite by adjacent is tangent. So for that angle, opposite by adjacent. For another angle, opposite by adjacent. Okay, clear? That is what tangent is. So you know how to, you all people know how to compute tangent for one angle. Clear? So this kandupidichira mudiyuma? Tan A minus tan B divided by 1 plus tan A. Now they have asked the question with respect to R, not with respect to Bxy or Byx. If it is asked with respect to Bxy or Byx, you should consider the numerator. But it is asked with respect to R. What's the formula for R? Bxy, the product of two regression coefficients. Product of two regression coefficients. What is the product? What is regression coefficient? Tangent of an angle. Tangent of an angle. Tangent of an angle is equal to slope. Slope is equal to B. So this is nothing but slope. This is nothing but product of slope, which is R square. Which is nothing but R square. Now, angle between the regression line decreases. This value decreases when the denominator increases, right? When denominator will increase?
R increases.
Clear? Such a good question, right? Copied? Copied? Use the same method to find regression lines become identical when R is. What is meant by identical? If two regression lines are identical, what can you say about the angle between two regression lines? Will it be perpendicular? Will it be perpendicular or will it be parallel? Parallel. It should be parallel. Both the regression lines should be parallel or coincide. It can be anything. Either it should coincide or it should be parallel to each other. If it is parallel, what can you say about the difference between the angle? 0. Appo numerator is 0. Appo in such scenario, numerator is 0. When numerator will be 0? Okay. Regression lines become identical when R is. What can you say about R here? What can you say about R? The question itself is hidden in that, like the answer is hidden. You have to think. The numerator should be 0. The numerator should be 0. We don't know about the denominator because R is placed in the denominator only. But we know if one regression coefficient is greater than 1, other will always be lesser than 1. Right? With this, can we tell anything? With this, can we tell anything? Wait, when there will be a regression line? If there is a regression line, what can we say? There is a relationship between two variables. So correlation can't be 0. Correlation can't be 0. Ruled out. This option is ruled out. When correlation is -1. What is correlation -1? So the line is in opposite direction. The line is in negative direction. The slope is -1. So that is also not possible because they have given it to be identical. They haven't mentioned coincide. Identical means in same direction also. Right? So in such situation, +1 is the answer. In such situation, +1 is the answer. If it is given to be coincide, plus or minus 1 both will come. So try to check if there is a modulus of R. If there is a modulus of R, +1. Or in case if anywhere in the option plus or minus 1, -1, +1, plus or minus 1 is given, plus or minus 1 is the answer. If plus or minus 1 is also not given, modulus is also not given. If it is identical, your assumption should be on same direction, so it's +1. If the question is in opposite direction, the angle between them is 180. Instead of 0, the angle between them is 180. What can you say? It's -1 there. It's -1 there. Regression coefficients are unaffected by change in origin. Clear? Now, finally we have completed regression. Can we proceed towards skewness? Skewness I won't solve in about 15 minutes. Let me complete skewness and give you the break. If skewness is also completed, 60 to 70% of your portions are over. 60% of your portions is over. We are yet to complete with one big chapter, probability, which is a combination of set language and permutation combination. If that is also completed, another 20 to 25% is over. Remaining left out is time and distance, that equation part, calculus. That's the permutation. I will teach it along with permutation. Simple questions. Those are feeble chapters, man. Just apply the formula, you will get the answer. I won't be teaching sums here for time series, index numbers. I will give you the formula, apply this formula, this is the answer. That is what I am going to tell. The chapter is, that's it. Nothing is given in that chapter. Satisfied with regression? Satisfied with regression? Now, skewness. I don't know, like, let me take the module number.
Sir, what is skewness, sir?
சொல்றேன் பார். I will.
First time எடுக்க போறீங்களா?
See, module 5.5 skewness. I'm again asking you, are you satisfied with correlation and regression? Because for sure a question will come, kind of 6 to 7 questions will come from correlation and regression, or at least 6 questions. This is the chapter which you are going to study once again in your final. Are you satisfied with this? No. If you are satisfied, then 22 marks for your final 400 is written now itself. So we set a lower bound to your final, not my final, to your final. We give you that much confidence, that much clarity. Even in foundation level, you will get the motivation to write final. How itself. Skewness. While having the discussion on measure of central tendency, at the last part I mentioned about any data set where mean equal to median equal to mode, we called it as symmetric data. We called it as symmetric data. In general, the population is symmetric. In general, the population is symmetric, but it's not able to measure the entire population. So theoretically only this symmetric data is possible. Practically symmetric data is not possible. We don't have a evidential data to prove a symmetric data, to prove the symmetricity of data, because it's not possible to measure the entire population. Just because of that, this is a theoretical concept. That's why its importance is much limited. In a symmetric data, if you try to plot the frequency curve, what is frequency curve? Split the entire data into class intervals, try to find the mode. So you will be going for histogram. Each midpoint of the histogram, join it through freehand curve. That is what we call it as frequency curve. That frequency curve will be a bell-shaped curve. Where mean equal to median equal to mode. Clear? Where mean will be, median will be equal to mode. Now, what is skewness? As I mentioned, this is a symmetric data. This is a theoretical one. We are in practical life. Even subject itself is a practical subject. Unlike economics and law, it's not a theoretical subject. Now, this is my original data. This is my theoretical data. Now I am plotting my data. This is the frequency curve of my data, which is shifted towards the left hand side, right? And I am having one more data which got shifted towards the right hand side. So both of these curves suffer from lack of symmetricity, right? Lack of symmetricity. Such lack of symmetry is what we call it as skewness. Such lack of symmetricity is called as skewness. So a skewed diagram, a skewed data represent it got shifted from the symmetricity. That's what we call it as skewed data. If it is towards left, we call it as negatively skewed. If it is shifted towards left. Similarly, if it is shifted towards right, we call it as positively skewed. Clear? So in a negatively skewed data, mean will be lesser than median, will be lesser than mode. In a positively skewed data, mean will be greater than median, will be greater than mode. Mean will be greater than median, will be greater than mode. This is the properties of skewness. It will be shifted, positively skewed data will be shifted towards the right and a negatively skewed data will be shifted towards the left. Just a minute. Hope you remember I am having this left and right issue. That's why I had a thought something is missing. If it is negatively skewed data, it will be shifted towards the right. If it is positively skewed data, it will be shifted towards left. இப்போ கிளியரா இருக்கு. எழுதினவனும் அப்படியே எழுதியிருக்கோம். Clear, right? Clear, right? So we have two formula to find skewness. We have two formula to find skewness.
right ல மென்ஷன் பண்ணிக்கலாம் கிராஃப் அந்த சைடு பார்த்துக்கலாம்.
Carl Pearson skewness. Carl Pearson skewness.
So that one is set.
And Bowley skewness. When it comes to Carl Pearson skewness, divided by standard deviation. It's mean minus mode divided by standard deviation. In case of non-availability of mode, we can also use the formula 3 times mean minus median divided by standard deviation when non-availability of mode. What's the formula for mode?
L plus F0
Empirical formula.
okay, 3 median minus
3 median minus 2 mean, right? Minus mode. Upper minus 3 median, minus of minus plus 2 mean. So 3 mean minus 3 median. 3 times mean minus median. Now, when it comes to Bowley's coefficient of skewness, it will be Q3 plus Q1 minus 2 times median divided by Q3 minus Q1. The thing is, he played with quartile deviation. He played well with quartile deviations. Just with quartile deviation, he found the skewness. Can we? That's it with skewness. That's it with skewness. Correlation lies in between. Anyway, we haven't touched it. Probability lies in between. Abdiya, minus 1 to plus 1. It's 0 to 1. Regression, it's not exactly minus 1 and plus 1. If one is greater than 1, another one will be lesser than 1. Whereas when it comes to skewness, it always ranges between minus 3 to plus 3.
close interval.
Yeah. Now,
The bubble. It will open.
we have one more concept called kurtosis.
Sir, எங்க சொன்னீங்களா?
But it's not given in CMA syllabus, not briefly given in CMA syllabus, but let me teach it. Now we have discussed the shifting towards left or right. We have discussed the shifting towards left or right. Shifting of curve towards the left hand side or right hand side, we called it skewness. If the shifting is towards top or bottom, it's kurtosis. It's kurtosis. Height of the symmetric data. In kurtosis, we will be seeing three kinds of data, like three kinds of kurtosis. In all the types, it will be a symmetric data. It will be a symmetric data. It will be, skewness will be measured with beta 1 and kurtosis will be measured with beta 2. You don't need the formula for beta 1 and beta 2. It will be given in terms of moments. Just learn beta 1 and beta 2 represents skewness and kurtosis. It's a range. It's just a comparison. If it is more than 3, if it is less than 3, if it is 0. More than 3, less than 3, exactly equal to 3. If it is exactly equal to 3, we call it as mesokurtic. It's just terms. Mesokurtic. If it is less than 3, we call it as platykurtic. If it is greater than 3, we call it as leptokurtic. Clear? Sorry.
Beta 2.
Clear? That's it with the initial stages of statistics. That is, we have completed the interpretation level of statistics, or the analysis of statistics itself is completed. Then we have to go for prediction level, which is probability. Part 2 of the video.